Like I said, here we are, question 10. A supermarket sells tinned fruit in two different sizes. The containers are similar, because if they weren't we can't do the maths, can we? The large container contains 4 kilos of fruit and the little one contains 500 grams of fruit. Straight away notice mixed units. So let's just draw the little containers. So let me pretend that they're tins. That's the baby one and that's the big mummy one. Alright, so what have we got here? This contains 500 grams, which is basically 0.5 kilograms, and this contains 4 kilograms, so we don't have any mixed units. Now that's all good, isn't it? Now please note, if you contain mass or weight, to put it loosely, you must be occupying three-dimensional space, mustn't you? Because if you're completely flat and you're not in 3D, you don't have any mass, you don't have any weight whatsoever. So therefore, even though this is not a length in centimeters cubed or liters, it has to be treated as a volume, because you have weight or mass, you must have volume. Therefore we can take the ratio of the weights as equivalent to the ratio of their volumes. Okay, just get that into your head a minute. The ratio of their weights, 0.5 to 4, is equivalent to the ratio of their volumes. Alright? Now the height of the smaller one, so that height there is 14 centimeters. And what is the height of the larger tin? Essentially, what is the height there? Alright, so that's me setting up the calculation. Let's just do a volume ratio now. Now this is unusual. We've not done one of these where we have to work backwards. So here's the volume ratio. We have got 0.5 kilograms to 4, otherwise known as 1 to 8. Let's just double up and keep it all nice and simple. Now I want to take this ratio and work out the height of the bigger one. Now look, the ratio of the volumes is 1 to 8. That doesn't mean to say that the large height is 8 times as big as the small height. No. How do we get from linear ratio to volume ratio? We cube the linear ratio. How do you get down from volume ratio all the way back down to the basic linear ratio? You cube root it. So here we go. So the linear ratio is going to be the cube root of 1 compared with the cube root of 8. And of course the cube root of 1 is 1 and the cube root of 8 mercifully is just 2. So really the linear ratio is 1 to 2. So if the smaller one, which corresponds to the ratio part 1, is 14 centimeters, then the larger part 2 will be twice as big as the 14. So that's easy. Therefore the height is going to be 2 lots of 14 centimeters, otherwise known as 28 centimeters. And that's lovely, okay? So I've doubled the height, but I've increased my weight by 8 times. Do you see that? 1 to 8 as opposed to 1 to 2 on the linear ratio. But yeah, I've had to work backwards by cube rooting down to linear, then using the linear ratio to see that it's enlargement of times 2. So I just simply multiplied the 14 by 2 to get my 28, and that's all there is to it. Okay, I'll try and do 11 without crying. Again, this is totally unprepped. I think I'll say 12. It's really complicated for another video, so it's worth its own space in time. Right, 2 ice cream cones are similar. I think I'll draw them. So ice cream cone, there it is. There's a BB one. 2 ice cream cones are similar. The curved surface area of the large one. Alright, so let's draw the large cone. Yummy, yummy, full of lovely, lovely ice cream. So the curved surface area is 65 pi centimeters squared. So let's just say A equals, and the curved surface of the smaller one is that. So the area of the surface there is going to be 16.25 pi centimeters squared. Now please note, this means it's dangerous. And also watch that you're given the areas in terms of pi. You don't have to multiply the 65 by 3.14. You don't have to multiply the 16.25 by 3.14. That just makes the maths unnecessarily complicated. Now, the volume of the little one, small cone, right, so volume equals 12.5 centimeters cubed. Find the volume of the large one. So V equals, I don't know. But here we go. I've got an area and a volume, an area and I don't have a volume. Again, this is trickier than question 10 a moment ago. We've got area ratio to work with, so let's just write that down. The area ratio is going to be 16.25 times pi compared with 65 pi's. Is that alright? Let's just cancel the pi's, they've gone bye-byes. If I divide both sides by 16.25, I should reduce down the area ratio quite nicely. So let me just do that. So 16.25 divided by himself is 1, and 65 divided by 16.25, it won't be perfect. Yes it is, it's 4. There you go. So the area ratio is 1 to 4. Now there is no easy direct link whereby we go from area ratio and upgrade to volume ratio, but we can downgrade to linear. How do you do that? Well, quite simple. You take the area ratio and you square root it. By square root, I mean you don't put the 2 there, put a little 2 outside. The square root of 1, and of course the square root of 4. Well, the square root of 1 is 1, and the square root of 4 is 2. So as you can see, the linear ratio is 1 to 2. So if I knew the radius here, for example, then this radius would be twice as big. Okay, that's what it's teaching me there. Or if I knew the height here, then this height would be twice as big. All right? But they don't want to know radii and heights. They want to know the volume of the big cone. Now let me just work up here. We have the linear ratio of 1 to 2. So you take the volume ratio now. How do you go volume ratio? Well, you take the linear ratio and you cube it to take it into 3 dimensions. Well, 1 cubed is 1, 2 cubed is 8. Therefore, the volume of this cone is 8 times as big as the volume of the small cone. So what do? I take the little one, it's therefore 12.5 centimeters cubed, and I multiply that by 8 times to upgrade to my large cone of ice cream, which is delicious. 12.5 times 8 is exactly 100 centimeters cubed of delicious ice cream, or whatever you're going to show. Oh, it is ice cream. Ah, oh, lovely. Oh, what do I like? Ice cream. I like all ice cream, all flavours, trust me. Now, it's good for you as well, nice and creamy. Right, so that's it. Let's just review this one, alright? We're given the ratio of areas. There it is, 1 to 4, once you cancel the pi's. You square root down to get the linear ratio, and then cube the linear ratio to get the volume ratio, then use the volume ratio to work out the missing volume. Alright, so essentially, I take my 12.5, multiply that by 8, and I get my 100 centimeters cubed delicious cool ice cream. And I'm going to stop there and start worrying about question 12 because it's got everything in it. I'll be back quite soon.